Hello and welcome to the Terraform for Absolute Beginners course. In this course, we will learn how to work with the infrastructure as code tool known as Terraform. But first of all, let's understand what does infrastructure as code mean. Infrastructure as code means creating, updating, and destroying infrastructure using code. So we can easily and consistently create, update, or destroy infrastructure resources like servers, VMs, databases, networks, and more using code. In this course, we will start with the core concepts of Terraform, like the Terraform workflow, and we will gradually move on to more advanced topics to unlock the power of Terraform in provisioning and managing infrastructure. This course consists on theoretical lectures to break down complex concepts using animations and illustrations, and we will have also some hands-on labs to practice working with Terraform. So that's all about the introduction. I hope that you are excited to start this course, and I hope that you enjoy watching it. In this lecture, we will take a closer look to the Terraform workflow. The Terraform workflow consists basically of four main steps. First of all, creating the configuration file, then running the Terraform init command, and after that running the Terraform plan command, and finally running the Terraform apply command. Let's see what happens in each step in more details. So the first step to work with Terraform is to create a directory for your Terraform project and then write the Terraform configuration file, usually called main.tf. In this configuration file, you will define the desired state of your infrastructure using HCL, which stands for HashiCorp Configuration Language. If you want to split the configuration into multiple files, you can do that by creating multiple files. All of them should be with the .tf extension. Once the configuration files are ready, now you have to run the Terraform init command in your project directory. This command will initialize the working directory and install the required providers. Here in our situation, only one single provider is required, which is the local provider. These providers will enable Terraform to interact with the infrastructure and let Terraform create, update, or destroy resources when needed. By running this command, a folder called .terraform will be created in your Terraform project directory, where the required providers will be stored. An important note to mention here: as long as we still work with the same providers, there is no need to run the Terraform init command again. The Terraform init command should be run only if you start using a new provider, and you have to run this command to install this new provider. We will learn more about providers in the upcoming lecture. After initializing the working directory and installing the required providers, now we can run the Terraform plan command to generate the execution plan. This command will compare the state of your infrastructure with the desired state defined in your configuration file and shows you the changes that Terraform will make to the infrastructure. It will tell you about the resources that will be either created, updated, or destroyed. We see here that only one resource will be created, which is a file, and there is no resource that will be changed or destroyed. The Terraform plan command is not strictly required, so you can skip this step if you want, but it is highly recommended as a best practice in the Terraform workflow. The primary purpose of the Terraform plan command is to provide you with an execution plan before you actually apply the changes to your infrastructure. Now, if the plan looks good and you are happy with that, you can apply the changes using the Terraform apply command. The Terraform apply command will make the infrastructure up to date as you mentioned in the Terraform configuration file. And by running this command, a file called terraform.tf_state will be created. This file contains information about the resources that Terraform has created and their current configuration. We will learn about the state in Terraform in more details in a separate lecture. So that's an overview of the Terraform workflow. I hope that everything is clear, and thank you very much. Hello and welcome to this lecture. In this lecture, we will learn the basics of HCL. HCL is the abbreviation of the HashiCorp configuration language, the language on which is based the Terraform configuration language that we use to write Terraform configuration files to tell Terraform what plugins to install, what infrastructure to create, and to describe the desired state that we want our infrastructure to look like. Before talking about HCL, the language that we use to write a Terraform configuration file, you have to know that the name of a Terraform configuration file must end with the .tf extension, and this enables Terraform to understand and to read the content of the file. The HashiCorp configuration language consists of two main concepts, which are arguments and blocks. We will discuss first of all what are arguments, and then we will see what are blocks. When we talk about an argument in HCL, we talk about a key value pair, which represents an assignment of a particular value to a specific name. For example, for the key value pair that we have here, we are assigning the value file.txt to file name. The name before the equal sign is the name of the argument, and the value after the equal sign represents the argument's value. The same for the content argument. Here we are assigning the value welcome to Terraform to content, so content is the name of the argument, and the text welcome to Terraform is the value given to this argument. Let's move now to the concept of blocks in HCL. A block in the HashiCorp configuration language is a container for other content, starting with an opening curly brace which indicates the beginning of the block body, and ending with a closing curly brace which indicates the end of the block body. We will see what we can put in the body of the block in a few minutes. What we have to know here is that a block must be always preceded with a keyword representing the block type, which will specify the purpose of this block. In other words, why we are declaring and using this block. And depending on the block type, a set of labels must be mentioned between the keyword representing the block type and the opening curly brace, which indicates the beginning of the block body. We have many types of block, and here are a few types that we will use a lot when working with Terraform. To understand more the differences between block types, let's see an example of using a block of type resource and another block of type input. We want here to declare two blocks, one for creating a resource, for example a file, and another block for declaring an input variable. The two blocks will have the same structure, so both of them are delimited with curly braces. We will not focus now on the content of these blocks. The first thing that will make these blocks different from each other is the block type. The first block is used for creating a resource, so it must be of type resource. So whenever you want to create a resource with Terraform, you have to declare a block of type resource. For the second block, it is used to declare an input variable, so the type of this block must be input. And we have seen that depending on the block type, you have to add a set of labels after the block type. For a block of type resource, we have to add two labels. One representing the resource type, it means what you want to create or to provision, and the second representing the name that you want to give to this resource. For example, here we want to create a file, so the resource type must be local file, and we want to call this resource my file. We will learn later more about blocks of type resource in one of the upcoming lectures. The main purpose of this illustration is to understand the differences between two blocks of different types. For the second block, which is of type input, only one label is required, which represents the name given to this input variable. So here we are using a block of type input to declare an input variable called file name. Let's move now to the content of a block and see what we can put in the block body between the curly braces. In the block body between the curly braces, a set of arguments can be mentioned, and this depends on the block type. And if the block is of type resource, so it is used to create a resource, the arguments depends on the resource type. And in addition to arguments, further blocks can be nested in the block body with their associated arguments. Let's go back to the previous examples that we have discussed earlier to create a file and to declare an input variable. In the body of the resource block used to create a file, we have to specify two arguments, which are the file name argument and the content argument. You have to know that these arguments are not optional. So whenever we use the local file resource type, we have to mention these two arguments. Depending on the resource type that you are using, there are some arguments that are optional, so you can decide whether you want to specify them or not, and there are some arguments that are required, so they must be set in the resource block. For the second block that we have here, which is used to declare an input variable, we can't leave it empty because all the arguments of a block of type input are optional. But you can set some optional arguments. For example, you can set the type of the variable using the type argument, and you can give the variable a default value using the default argument. Finally, I want to tell you that the purpose of this lecture is to learn the basics of the HashiCorp configuration language and to be familiar with blocks and arguments, which are the cornerstone for writing Terraform configuration files. So you didn't need to focus a lot on the block types that we have seen here or the arguments that we have worked with. So just focus on what are arguments, what are blocks, and what we can put before and in the body of a block. And that's the purpose of this lecture. So I hope that everything is clear, and see you next time. We will learn in this lecture how to create resources with Terraform. A resource in Terraform is the infrastructure object that we want to create. For example, it can be a compute instance, a virtual network, or any other infrastructure object. The first thing that we need to create resources with Terraform is a file with the .tf extension. So let's create here a file, for example, call it main. and it should be with the .tf extension. To create a resource in Terraform, we need a resource block. A block is a container of data, and the type of the block that we need here to create a resource is a resource block. We will see later some other type of blocks, like a variable block to work with input variables. So here we need a block of type resource. So here the resource keyword is used to specify the type of the block. After the resource keyword, we have to mention the provider and the resource type that we want to create. A provider is a plugin that will allow Terraform to interact with the infrastructure. There are many providers for different platforms. So for example, if you want to create resources on a cloud platform like Azure, so here you have to use the Azure provider. Here we want to create a resource locally on our system. So here we will use the local provider. And the type of the resource that we want to create here is a very simple resource, which is a file. So here we have _ file. So here, file is the type of the resource that we want to create, and local is the provider that we will use to create this resource. After that, we have to give a name to our resource. So for example, here I can call the resource that we will create just my file. So here the resource keyword is the type of the block, and for local file, so here local is the provider that we will use, and file is the type of the resource that we will create. And my file is a name given to the resource that we will create. And now here in the body of the block, we will mention the arguments needed to create this resource. This depends on the resource that we want to create. For example, here if we go to the browser and search for Terraform, so let's go here to the providers. So here we have different providers to interact with different cloud platforms like Azure, Google Cloud. If we go here to the bottom, we find the local provider that we use to create resources locally. So if we go here to the documentation, we find here under resources, the resources that we can create using this provider. Here is the local file, which is the type of the resource that we will create in our situation. And if we go here to the bottom, here we find the required arguments that we have to mention in the body of the resource block. And here we find a set of optional arguments that we can use when we define a resource. So here we have to define the file name argument, and we can use some other optional arguments. So here we will use the file name argument, which is the required argument. So here I want to create a file in the current working directory and call it file.txt. Okay, so here only the file name is required, but we can use some optional arguments like the content to specify the content of this file. For example, I will store in this file a very simple message like, "Hi, how are you?" So now the Terraform file is ready to create a resource, which is a file. The next step is to initialize the provider. Here Terraform will check the Terraform file and detects the provider needed to be initialized to create this resource. And to do that, we have to execute the Terraform init command. So here Terraform is initializing the provider plugins. So it installed the HashiCorp local provider, which is the provider needed here to create this resource. And you notice here that a folder called .terraform is added, which is the location of the providers. So if we explore this folder, we find here the local provider. The next step is to run the Terraform plan command to see the changes that will happen to the infrastructure. So here Terraform will tell you what resources will be created and what resources will be changed or destroyed. Here the plus sign means that the resource will be created. Here we have only one resource that will be created, which is the resource defined using this resource block. Okay, so here we find that one resource will be added and no resource will be changed or destroyed. This command is optional and it doesn't make any change to the infrastructure. And now to apply this plan, to apply those changes, we use the Terraform apply command. The Terraform apply command will apply the changes that we saw with the Terraform plan command. So here we see again the resources that will be created, and here Terraform asks you to confirm performing this action by entering yes and press enter. And here we see that the apply was completed, and so one resource was added and no resource was changed or destroyed. And here is the file created with Terraform. So it is called a file with the content, "Hi, how are you?" as we mentioned here in the main.tf file. So that's a very simple example of creating resources with Terraform. I hope that everything is clear, and see you next time. Let's see in this lecture what happens if we try to update a resource with Terraform. We have created previously this file with Terraform with this content. We will make a very simple change to the content. We will add just an exclamation mark at the end of the string. So here at the end of the string we will add an exclamation mark. Now to update the file with Terraform, we didn't need to run the Terraform init command again because we still work with a single provider, which is the local provider that is already initialized from the last time when we create the file. Let's now execute the Terraform plan command to create the execution plan, which let us preview the changes that Terraform plans to make to our infrastructure. So here to see the changes that Terraform will make to the infrastructure, we run the Terraform plan. So you see here at the beginning this minus plus symbol. The minus plus symbol implies that the resource will be destroyed and then recreated. That's why this type of infrastructure is known as immutable infrastructure. Immutable infrastructure means that the infra can't be changed once it is created. If you want to make some updates, the only way to do that is to destroy the current version and create another one with the desired updates. So here when we run the Terraform apply command, here Terraform will delete this file and will create another file with the same name but with this updated content. Okay, So let's enter yes here. And here at the bottom, we see that one resource is added and one resource was destroyed. Okay. So here, Terraform, it doesn't update the same file. It deletes the existing file and it creates a new file with this updated content. And this type of infrastructure is called immutable infrastructure. So you cannot make changes to the existing infrastructure. So here Terraform doesn't change the existing resource. It deletes the existing resource and create a new one with the desired changes. In this lecture, we'll learn more about providers in Terraform. In Terraform, a provider is a plugin that defines how to interact with a specific infrastructure platform. They are responsible for translating the Terraform configuration into API calls and managing the lifecycle of the resources within the specified platform. So they act as the bridge between Terraform and the target infrastructure. Terraform has a rich ecosystem of providers that support various cloud providers, on-premises infrastructure, and other services. Common examples include AWS, Azure, and Google Cloud Platform, and more. Each provider supports a set of resource types representing the various infrastructure components you can manage. For example, the AWS provider supports resource types like AWS Instance, AWS S3 Bucket, and so on. We will see later how to view the list of resource types supported by a specific provider. In addition to resources, providers also offer data sources, which allow you to query and retrieve information from the infrastructure without creating new resources. So data sources are read-only and useful for gathering information about existing infrastructure. We'll see later how to work with data sources in Terraform. In Terraform, providers can be classified into official, partner, and community providers. If you want to see the list of official providers, you can visit the link registry.terraform.io/browse/providers and then choose official, and you will get the list of official providers. Official providers are developed and maintained by the HashiCorp team, the creator of Terraform. They are considered the primary and most widely supported providers for various infrastructure platforms and services. Users can rely on official providers for their stability, regular updates, and their comprehensive documentation. For partner providers, they are developed and maintained by a technology partner in collaboration with HashiCorp. To view the list of partner providers, visit the same page and now keep only the partner choice checked. These providers have met certain criteria for their level of quality and their compatibility similar to official providers, and that's why they are recognized as trustworthy and supported within the Terraform ecosystem. And finally, for the community providers, they are available in the same page and just now keep only the community checkbox checked. Community providers are developed by the broader Terraform community and are not directly maintained or supported by HashiCorp. These providers are contributed by individual developers or organizations who have specific use cases or requirements. HashiCorp does not provide official support for community providers, and their maintenance and updates depend on the contributors. Let's now see how to use providers when working with Terraform. We saw previously that after writing the configuration file in Terraform, you have to run the Terraform init command, which will initialize your project directory, and download the required providers based on the resource types mentioned in the configuration file. You can list the providers required by the configuration using the Terraform providers command. You see here that only the local provider is required. By default, Terraform will install the latest version of the required providers. But if you want to use a specific version, you can specify the version that you want in the configuration file, like that. So here we add the Terraform block where we mention the required providers. So here, instead of using the latest version, we want to use the version 2.3.0 of the local provider. And if we run the Terraform providers command now, we will see that the version 2.3.0 of the local provider is required for this configuration. So that's it for now. I hope that everything is clear, and thank you very much. So we saw in the last video what are providers and how to work with them. And in this video, we will learn more about providers. So to see all the providers in Terraform, here we search for Terraform providers. And here is the official website of Terraform, where you find all the providers, which is registry.terraform.io. So let's click here. And now we get all the providers supported by Terraform. Okay, so here we get all the providers, the official, the partner, and the community providers. If you want only to view the official providers, so here just keep only official, the official checkbox checked, and now we get only the official providers, including AWS, Azure, and Google Cloud providers. And here you find also the local provider, which is used to create resources locally on our system. Here also we find the random provider, which is a provider used to create some logical resources, such as random string or a random integer. Okay, the same if you want to see only the partner providers. So here we keep only the partner checkbox checked, and you see here the list of the partner providers. And the same for the community providers, which is the providers developed by the Terraform community. Now let's go back to the official providers. Let's say that we want here to use the Google Cloud provider to provision some resources on Google Cloud. So to see the resources that we can create with Google Cloud and how to create them with Terraform, so let's go here to the documentation of the Google Cloud provider. So here we find the latest version of this provider, which is 5.8.0. If we click here on this version, we will get the previous versions. If you want to see all the version of this provider, so just click here on view all versions, and here you find all the versions of this provider. Now if you want to use a specific version of this provider, so just click here on use a provider, and you have to take this block of code, and then you have to set the version to the version that you want to use. For example, if we want to use the version 5.7.0, here instead of setting the version to 5.8.0, we set it to 5.7.0. Okay, we will do that later with the local provider. Now to see the resources that we can create with this provider, we go here to the documentation, and here we find the resources categorized into different categories. Okay, we can search here, for example, for cloud storage. Let's say that we want, for example, to create a bucket. So let's search for cloud storage. So here under the cloud storage category, we find some resources that we can create here. One of them is the Google Cloud storage bucket. Here we will find how to create this resource with Terraform. If we go here to the bottom, we will find the arguments of this resource. You see here that some arguments are required. So when we create a bucket in Google Cloud with Terraform, we have to give a name to the bucket and we have to set the location. Okay, and we find also some other optional arguments. So these arguments are not required. Only the name and the location are required. So when we create a bucket with Terraform in Google Cloud, we have to give the bucket a name, and we have also to set the location. We find here also the data sources. We will learn about them later. And here we have an example of a Terraform code for creating a bucket in Google Cloud. So here we have a block of type resource, and the resource type is Google storage bucket. The name of the resource is auto expire. And here we set some arguments for this resource. Okay, as we said previously, only the name and the location are required, and the other arguments are optional. And the same story if we want to work with any provider. For example, here if we go to local, so let's see how we can work with the local provider. Here the same thing, we find the latest version of this provider, which is 2.4.0. If you want to see the previous version, so click here on this version and you will get the previous versions. And if you click here on view all versions, we find all the versions of this provider. To see the resources that we can create with the local provider, so let's go here to documentation. And here under resources, so here we can create a local file or a local sensitive file. The difference between a local file and a local sensitive file is that when we create a local file, the content of the file will be displayed on the screen when we run the Terraform plan command or when we run the Terraform apply command. Okay, but with local sensitive file, the content will be not displayed on the screen. Okay, so when we create a resource of type local sensitive file, here the content of the file will be not displayed on the screen when we run either the Terraform plan command or the Terraform init command. So let's go back here to VS Code. Here if we run the Terraform providers command, here we get the list of providers required by this configuration. So when we run the Terraform init command, this provider will be installed. Here by default, Terraform always will install the latest version of the provider. If you want to use a specific version, so let's go back here to the browser, and let's say that we want to use the version 2.3.0. So here we will take this block of code. Let's go back to VS Code. So here we will add the Terraform block in the top of the file. Here, instead of setting the version to the latest version, which is 2.4.0, we will set it to 2.3.0, okay? Because we want to use this version of the local provider. Now, if we execute the Terraform providers command again, we will see that now the providers required by this configuration is the local provider, and specifically this version. Okay, so here the version 2.3.0 of the local provider is the only provider required for this configuration. Now if we run the Terraform init command, so here Terraform will install this version, the version 2.3.0 instead of the latest version. So here Terraform has been successfully initialized, and the HashiCorp local provider was installed, and specifically the version 2.3.0. So that's how we can tell Terraform that we want to use a specific version of a provider. So here we use the Terraform block, and inside this block we add a block called required providers, and here we set the version of the provider. Okay, so that's it for now. I hope that everything is clear, and thank you very much. The first thing we have to do after creating the configuration file with Terraform is to run the Terraform init command. The Terraform init command will check the configuration file and initialize the providers needed to let Terraform interact with the infrastructure. As long as we still work with the same providers, there is no need to execute this command again. For example, we can add in this configuration file a resource block for creating another file. So here let's add a new resource block, and here we will make use of the local provider again to create a new file. Let's give our resource a name. For example, I will call it just count. Now let's move to the arguments. So for the file name, I will call the file count.txt, and for the content, I will store in this file this value 50. Okay. Now since the local provider was already initialized from the last time when we create the first file, there is no need to execute the Terraform init command again. So let's run the Terraform plan command to see the execution plan. So here Terraform will create a new resource which is of type file with this name count. We are happy with that, so let's run now the Terraform apply command. So let's confirm by entering yes, and here a new resource was added, and there is no resource changed or destroyed. Okay, and here we find the count.txt file with this content. Okay, so as long as we still use the same initialized provider, there is no need to run the Terraform init command. We will use now another provider called random, which is a logical provider, and that means that it works entirely with Terraform's logic, and it doesn't interact with any other service. Using this provider, we can create a set of resources such as a random ID, a random integer, and some other resources. Here we want to use the random provider to generate a random integer. So let's add here another resource block, and here we will use the random provider to generate a random integer. Okay, so let's give our resource a name, for example random int, And the arguments are required here for the random integer resource are the min and max arguments. So let's set the min to 10, for example, and max, we will set it to 20. So here, using the random provider, we will generate a random integer between 10 and 20, okay? If we run the Terraform plan command now, we will get an error telling us that we are using a provider that is not already initialized, which is the random provider. So here, if we run Terraform plan, we get this error because the random provider was not initialized. So let's initialize this provider using Terraform init. Here, the output of this command shows that Terraform installed the random provider with this version, and it makes use of the local provider that is previously installed. Okay, so whenever we make use of a new provider that is not already initialized, we have to run the Terraform init command to initialize this provider. And if you check now the content of this folder, the .terraform folder, we now to see that now we have two providers, the local provider and the random provider. So let's now run the Terraform plan command again to see the execution plan. So Terraform plan. So here a new resource of type random integer will be created. Now let's apply this plan using Terraform apply. So let's confirm by entering yes. So now a random integer was generated. You can check the integer that was generated using the Terraform show command. So here this command shows detailed information about the resources that was created. And here in the bottom we find the random int resource. And the generated integer is the value of the result attribute, which is 17. Okay. So what we have to know here is that as long as we make use of the same provider that is already initialized, there is no need to execute the Terraform init command again. We have to run this command only when we make use of a new provider that is not already initialized. Okay? So that's it for now, and see you next time. We will learn in this lecture how to work with input variables in Terraform. But before that, let's revise how to create a very simple resource with Terraform, such as a local file. To create a file with Terraform, we use a block of type resource, and we set the type of the block using the resource keyword. And then we tell Terraform that we want to create a file locally using the local file type. So here, local is the name of the provider, and file is the resource that we want to create using this provider. And then we give our resource a name such as my file, and then inside the block we set the arguments needed for this resource. So here we give the value /file.txt to the file name argument, and the saying hi, how are you, to the content argument. And finally, to create the file, we execute the Terraform init command to initialize the provider, and then the Terraform apply command to generate the execution plan, and finally the Terraform apply command to apply the execution plan. In this example, the values given to the arguments are hard-coded in the configuration file. It would be better if we can store these values in a separate location so they can be used for setting arguments of other resources. And instead of changing them in different places, we change them in one single central place. This flexible approach will allow us also to utilize the same configuration file across multiple environments or with different settings, simply by changing the assigned values to the variables. Another thing we have to mention here we work with simple data such as a file name or a file content, but when we work with sensitive data, it is recommended that you do not hardcode specific values such as API keys and passwords directly into your configuration. Instead, you should treat them as variables that can be dynamically provided when needed. All of that is achieved in Terraform using input variables. So instead of hard-coding the values in the configuration file, we can store them using input variables. To declare an input variable, we add a block of type variable. So here the variable keyword is used to set the type of the block. This is followed by a label, which is the name given to the input variable. And then to store a value in this variable, we can use the default argument followed by the value that we want to give to this variable. We can store variables and resource blocks in the same configuration file, but as a convention, variable should be declared in a separate file called variables.tf. Okay, so here we will add a new file and we will call it variables.tf, and here we will declare our input variables. So let's take this block of code and put it here in the variables.tf. Here we will declare two input variables, one called file name to store this value, and another called content for this value. So here, first of all, we will declare a variable called file name, and in this variable we will store the value given here to the file name argument. The same for the content argument. So we will declare another variable and call it content, and here we will store the value given to the content argument. So we will take this value from here and put it here for the default argument of the content variable. So now we have declared two variables, one called file name with the value ./file.txt and another called content with the value of type string, which is hi, how are you? Now the value stored in an input variable can be accessed using var.the name of the variable. So here, for example, to access the value stored in the file name argument, here we will use var.the name of the variable, which is file name. Okay. The same for the content. So we want to fetch the value stored here in this content variable, and that's done using var.content. Now let's open a terminal and try to create this resource. So first of all, we have to run the Terraform So Terraform init command to initialize the providers used in this configuration file. Here we have just one provider, which is the local provider. And now the provider was successfully initialized. So let's run the Terraform plan command to see the execution plan. We see here that we have only one resource that will be created, which is of type local file with this content, as we store it in the variables .tf file, and specifically in the content variable. Okay. For the name, it will be file.txt, as we mentioned here in the file name variable. Now let's apply this execution plan using Terraform apply. So let's confirm by entering yes. And now the file was successfully created. Here is the file.txt with the content, hi, how are you? So that's a basic usage of input variables in Terraform. We'll see more about variables in Terraform in the upcoming lectures. So that's it for now, and see you in the next lecture. We saw earlier how to work with input variables in Terraform. In this lecture, we will take an in-depth look to them. We have seen that we can declare an input variable using a variable block. So the variable keyword here will tell Terraform that this block is used to declare an input variable. The label after the variable keyword is the name given to the variable. This name will be used later to reference the variable's value when needed, for example, for setting some arguments in a resource block. And inside the variable block, we can assign a value to the variable using the default keyword. For example, here in the variables.tf file, we have declared two variables, one called file name and the other called content. We have assigned the value ./file.txt to the file name variable and the value welcome to Terraform to the content variable. Now this value can be accessed to set arguments in a resource block, and we can reference them as attributes of an object called var. For example, here we have set the file name argument of the local file resource using the file name variable, and the content argument using the content variable that we have declared in the variables.tf file. Now, when we apply this configuration file, a file called file.txt will be created with the content welcome to Terraform inside it. Let's learn now about variable types in Terraform. Terraform supports a set of simple types such as string. Here the value will be a sequence of characters representing some text such as server1, dev, welcome to Terraform, or whatever you want. We have also the type called number. The variable here will accept any numeric value. The number type can represent both whole numbers like 15 or 100 and fractional values such as 12.5 or 1.65. Finally, we have the type bool for Boolean values. Here, the value can be either true or false. If we don't specify the type of a variable or we set the type to any, the type of the variable will be any, and the variable will accept any value regardless of its type. Let's see now how we can set the type of a variable. We can set the type of a variable using the type argument in the variable block. For example, here in the variable.tf file, we have declared a variable called location, and its type is string, a variable called replica, which will accept any numeric value since its type is number. A variable called isSensitive. The type here is bool, so only true or false would be accepted. And finally, for the variable called env, we didn't specify the type here. That's why any value will be accepted. In addition to the default and type arguments, there are some arguments that we can set when declaring a variable. We have the description argument, which is used to give more information for what this variable is used for. The nullable argument in a variable block controls whether the variable can accept the value null. If it is true, the null value will be accepted. Otherwise, the variable will never be null. You should know that the default value for nullable is true. We have also another argument, and it is called sensitive. Setting a variable as sensitive prevents Terraform from showing its value when we use this variable in our configuration. By default, the variable is not sensitive, but if you want to turn it as a sensitive data, all you have to do is to set sensitive to true. Finally, we will talk about the validation argument. This argument is a block that we can use in a variable block to add more restriction on the values that can be assigned to this variable. For example, here, the length of the string given to the content variable should be greater than 4. Otherwise, you will get an error telling you that the given value is invalid. So these are all the arguments of a variable block. You have to know that all of them are optional, and a variable can be declared simply like this without setting any argument. We will see what happens in such a case. So that's it for now. In the next lecture, we will learn about complex types in Terraform. So we saw in the last lecture how we can set the type of a variable in Terraform and the different arguments that we have for a variable block. And now we will see them with the practical examples. So to declare variables in Terraform, we will create here a file and call it variables.tf. First of all, I will add a block of type variable to declare a variable and call it file name. And to set the type of this variable, here I will use the type argument. So here I will set it to string. So now this variable will accept only values that belong to the type string. So for example, we can set it using the default argument to .count.txt. Okay. Let's declare another variable for the content. And I will set here the type of the variable to number. So this variable will accept only numeric values. And we will see that if we set it to another value, for example, a string, you will get an error when running either the Terraform plan command or the Terraform apply command. So now we will set it to a number, for example, 5. Now let's create the main.tf file. And here we want to create a local file, so we will declare a block of type resource. And the resource type is local file. The name that we will give to the resource is count file. And now inside the resource block, we have to set some arguments. For example, the file name. And here for setting this argument, we will use the variable that we have declared here, which is file name. So we will set it to var.filename, and the same for the content. Now let's run the Terraform init command to download the required providers. So now the required providers was installed, and if we explore here the content of the .terraform, we find here that we have the local provider. Okay. Now let's run the Terraform plan command to get the execution plan. So here you see that only one resource will be created, and there is no resource that will be changed or destroyed. Okay. And the resource that will be created is a local file with this name. So here is the name of the resource. Okay. Here you find the content that will be stored in the file, and here is the file name. Now let's run the Terraform apply command. So let's confirm by entering yes. Now the file was created. So it is called count.txt with the content 5, as we mentioned here in the variables .tf file. So here we set the type of the content variable to number. Here if we change the default value to a value that belongs to another type other than the number type, for example a string. Now when we run the Terraform plan or the Terraform apply command, we will get an error telling us that the value given to this variable must be of type number. So let's run the Terraform plan command. So here we get an error related to the content variable, and you see here that the default value is not compatible with the variable's type constraint. So here a number is required for the content variable. So let's go back to a value of type number, for example 5. Here we can set also another argument, which is the description. We use this argument just to describe for what this variable is used. For example here we can set the description to the content that will be stored in the file. We have also the nullable argument, which is by default it is true, but we can change it to false. So when it is false, the content variable will not accept the value null. Okay. So now if we set this the default value of the content variable to null, and now run the Terraform plan command, here Terraform tells us that a null default value is not valid when nullable is false. So because here the nullable argument is false, the content variable will not accept the value null. Here we need to change it to another value other than the null value, for example 10. We have also another argument called sensitive, but before setting the sensitive argument, let's run the Terraform plan command. So you see here that the content of this file will be changed from 5 to 10. Okay. So 10 is the value that we give here to the content variable. That's because by default the sensitive argument for any variable is false. If we set it to true, the value given to this variable will not be shown when we run the Terraform plan command or when we run the Terraform apply command. So here if we set the sensitive argument to true, So let's set it to true. Now if we run again the Terraform plan command, we will not see the value given to this variable, because here sensitive is true. So let's test that by running Terraform plan. So let's scroll to the beginning. Now we didn't see the value of the content argument, and that's because the value that we give here to the content variable that is used to set the content argument of the local file is sensitive. So when the variable is sensitive, the value given to this variable will not be shown by Terraform when we run the Terraform plan command or the Terraform apply command. Finally, we will see the validation argument. Let's remove the sensitive argument. So we use the validation argument to add more restriction on the value that can be accepted for this variable. So for example, here we can set the condition. So here is the condition, the var dot content should be greater than 10. And we will add an error message that will be displayed if this condition return false. So here we will set the error message, for example, the value must be greater than 10. And let's change this value to 9, for example. Now let's run the Terraform plan command. So here we get the error message that we have set here. The value must be greater than 10, because here we set the content variable to 9, which is not greater than 10. Okay, if we change it to 12, for example, now if we run the Terraform plan command, this error message will disappear because 12 is greater than 10, and this condition will return true. So let's test that by running Terraform plan. So here Terraform gives us the execution plan, and there is now error message. And here we see that the content will be changed from 5 to 12. Okay, let's run the Terraform apply command. And now let's confirm by entering yes. So now let's see the content of the count.txt file. And it is 12, as we mentioned here in the variables.tf file. Okay. Of course, we can declare also variables of type bool. So let's declare, for example, a variable and call it is required. Inside the resource block, we will set the type to bool. And here only true or false are accepted for this variable. Okay. And you can declare a variable of type any. So this variable will accept any value regardless of its type. Okay. So for example, here the data variable is of type any. So the value given to this variable can be a value of type number, or it can be a string, or it can be also of type bool, so it can be true or false. So that's it for now. In the next lecture, we will see the different methods for setting input variables in Terraform. In this lecture, we will discuss the complex types, also known as collection types, that we have in Terraform. These types will allow you to group multiple values of the same or different types within a single variable. We will discuss first of all the list type. A list is an ordered collection of values. Think of it like an array in other programming languages. Here is how to define a list in Terraform. We specify the type of the variable using the list constructor, and between the parentheses, we specify the type of elements that can be part of this list. Each element in a list can be accessed later by its index, starting from 0 for the first element, 1 for the second element, and so on. For example, here we have accessed the first element of the numbers list for setting the mean argument of the random integer resource, and the second element for setting the max argument. Now when we run the Terraform apply command, a random integer will be generated between 3 and 11, which are the values that we have stored in the list and accessed later for setting the mean and max arguments. Just a reminder about the random provider. The random provider is a logical provider used to generate random values such as a random string or random integer, and it doesn't interact with any other services. If we set the type of the list elements to any, as we did here, the list can contain a mix of values of different types, such as one which is a number, dev which is a string, and also true which is of type bool. But if we set the type to a list of numbers, for example, only numeric values will be allowed, and any value of any type other than the number type will generate an error. We will see now a few examples of lists. So the first list is a list of numbers containing 3 elements, which are 9, 21, and 5. The second one is a list of strings, so here only string values are allowed. Here we have also 3 elements, which are dev, test, and prod. And finally, for the last list, it is a list of any. That's why values of different types are accepted. Let's talk now about the set type. A set is a collection of values that does not allow duplicate elements. This can be handy when you want to ensure uniqueness within a group of elements. We tell Terraform that the variable is of type set using the set constructor, and between the parentheses, we mention the type of values that are allowed in this set. You have to note that unlike lists, you cannot access the elements of a set using their indexes. You can access the elements of a set by converting the set first of all to a list using the toList function, as we did in this example, and then access the elements of the list returned by the toList function by their indexes. A set of type any can have values of different types, but if you specify the type of the elements, only values that belong to this type will be accepted. Let's see more examples of sets. The first set that we have here is a set of numbers, so it must have only numeric values. But because here we have the value dev, which is of type string, the set will lead to an error while running the Terraform plan command or the Terraform apply command. The second one is a set of strings which contains 3 values, which are up1, up2, and up3. And finally, for the last set, it is a set of any, so it can have any value of any type. We will move now to the map type. A map is a collection of key value pairs. If the type of the elements of a map is any value given to a key will be accepted regardless of its type. But if you set the type to number, for example, only values of type numbers are allowed. After declaring a map, the values can be accessed later using the keys associated with these values. For example, here we set the file name argument of the local file resource using the value given to the key called file name of the map called file data, and the same for the content argument. If you run the Terraform apply now, a file called count.txt will be created with the value 11 inside it. Let's see now how to work with a map of a specific type. The map called numeric data must have only numeric values, not because it is called numeric data, the name can be anything, but because it is a map of numbers, so the value associated with any key must be of type number. For the second map here, it is called file data, and only values of type string are accepted. And finally, for the last map, it is a map of numbers, and an error will occur while running the Terraform plan or the Terraform apply command because the value associated with the content key is not of type number, it is of type string. We will see now how to work with tuples in Terraform. A tuple is an ordered collection of elements similar to a list. Here is an example of a tuple declared in Terraform. Values that match the tuple type must have a number of elements equal to the number of types mentioned between the square brackets when declaring the tuple. For the tuple that we have declared in the variables.df file, it will accept only 2 elements. If you set it to more or less elements than what we have mentioned between the square brackets, you will get an error. And in addition to that, the value in each position in the tuple must match the specified type for that position. For example, if we set the second element here to 3, which is a string, we will get an error because we have mentioned when we have declared the tuple that the second element must be of type number. Let's see now how to access the elements of a tuple. The elements of a tuple can be accessed by their indexes, starting from 0 for the first element, as we did for accessing the elements of a list. Here in this example, we have used the first item of the tuple for setting the file name argument and the second element for setting the content argument of the local file. Finally, we will talk about the object type. An object is a collection of named attributes, very similar to a map, but when working with objects, each attribute will have its own specific type. For example, here, the variable called numbers is of type object, and it has 2 attributes, one called maximum of type number, and another called minimum, also of type number. Values that match the object type must contain all the specified keys, and the value for each key must match its specified type. A value missing any key mentioned in the object declaration, as we have here in the second example, will not be accepted and will lead to an error. And the same if the value given to the key doesn't match its type. Here the minimum key is of type number, but we have set it to 3, which is a string. So here Terraform will throw an error indicating that a number is required for this key. Finally, we will see how to access the values stored in a variable of type object. To access the value stored in a variable of type object, we need first of all to access the variable as we did with any variable, followed by the attribute that belongs to the object declaration. In the example that we have here, we have used the file name attribute of the file settings object for setting the file name of the local file resource, and the content attribute for setting the content argument. By running the Terraform apply command now, a file called count.txt will be created with the value 5 inside it. So that's it for now. In the next lecture, we'll see the different methods for setting input variables in Terraform. We have seen earlier that input variables can be declared like this without setting any argument and without providing a default value for the variable. Let's see now what happens if we run the Terraform apply command in such a case and the different ways for supplying values for input variables. We have here two Terraform configuration files, one called variables.tf for declaring input variables, and another called main.tf for defining the resources that we want to create. In the variables.tf file, we have two input variables, one called file name and another called content, but we didn't set any argument for both variables. In the main.tf file, we have used these variables for setting the arguments of the local file resource. Since we didn't give any values for these variables, when we run the Terraform apply command, Terraform will ask us to enter a value for each input variable. And using these entered values, Terraform will create, update, and destroy resources as you mentioned in the configuration file. When input variables are declared in your configuration, they can be set in different ways. First of all, on the command line. You can set a variable on the command line in an interactive mode while running the Terraform apply command using the -var option, followed by the variable name and the value that you want to assign to this variable. If you have several variables that need to be set, you can use the -var option multiple times in a single command. We set here two variables on the command line. We assign the value welcome to the content variable and the value of file.txt to the file name variable using the -var option for each variable. And using these values, Terraform will make the infrastructure up to date as you mentioned in the configuration file. Setting variables on the command line can be not convenient, especially if you have a lot of variables that need to be set. A more convenient way in this situation is to set them using variable definitions file. A variable definitions file is a file that ends with .tfvars or .tfvars.json where you can set multiple variables. It is very similar to any Terraform configuration file, but it consists only of variable name assignments. If the file is named exactly terraform.tfvars or terraform.tfvars.json, or with any name that ends with .auto.tfvars or .auto.tfvars.json, Terraform will load the file automatically when applying your configuration by running the Terraform apply command, and there is no extra work that you have to do. Otherwise, you have to specify the variable definitions file while running the Terraform apply command using the -var-file option, followed by the name of the variable definitions file. Here the file is called values.tfvars, so the file will not be loaded automatically by Terraform, and you have to specify the file using the -var-file option to enable Terraform to use these values when creating the resources. Another way for setting input variables in Terraform is using environment variables. When we run the Terraform apply command, Terraform will search for environment variables called tf_var_, followed by the name of a declared variable. An input variable can be set using environment variables like this. We export an environment variable called tf_var_, ending with the name of the declared variable, followed by the value that we want to assign for this variable. For example, for setting the file name variable using environment variables, we will export an environment variable called tf_var_file name, followed by an equal sign, followed by the value that we want to assign to this variable. And the same for the content variable. Now when we run the Terraform apply command, Terraform will search for environment variables, starting with tf_var_. It will find two environment variables, one for setting the file name and another for setting the content. So it will use the given values for creating a resource of type local file. So here a file called welcome.txt will be created with the content welcome to Terraform inside it. So these are all the methods that we can use for setting input variables. We can set a variable in different places, for example in a variable definitions file and using environment variables, and also using the -var option. But this can lead to unexpected result if we didn't know how Terraform will take these values. Here, for example, we assign the value file.txt to the file name variable using an environment variable. In the terraform.dfvars file, it is set to myfile.txt. And in another variable definitions file called values.auto.dfvars, we set it to welcome_file.txt. And finally, in the data.dfvars, it is set to welcome.txt that we have passed to the Terraform apply command using the -var-file option. The question that you may ask here, which value will be taken when several values are provided? To answer this question, you have to understand, first of all, a variable definition precedence in Terraform. When we run the Terraform apply command, Terraform looks first of all if you have set input variables using environment variables. Then it loads the values assigned using the terraform.dfvars file, and if this file exists, the values defined in this file will override the values assigned using environment variables. Then if a file called terraform.dfvars.json exists, the values assigned here will override those that are assigned in the terraform.dfvars or using environment variables. Then Terraform will look if variables definitions files ending with .auto.dfvars or .auto.dfvars.json exist. If yes, they will be processed in their lexical order. And finally, the values assigned using the -var option or the -var-file option will override any previous values. So if we go back to our previous example, here we have used the -var-file option, which has the highest precedence. Therefore, Terraform will ignore all the values and will take the values mentioned in the data.dfvars file. So this is how Terraform will handle input variables if multiple values are provided for the same variable. So that's it for now, and see you next time. In this lecture, we will discuss another kind of variables in Terraform known as output variables. Let's understand first of all why and when we need output variables. We have seen that to generate a random integer with Terraform, we need a resource block of type random integer which belongs to the random provider. The required arguments for the random integer resource are only the main and the max arguments. After initializing the provider and running the Terraform apply command, we see the mean and the max arguments that we have set in the configuration file are displayed in the output of the Terraform apply command. But we didn't get the random value that will be generated by Terraform. The value will be stored in the result attribute of the random integer resource, but it can be known only after applying the configuration. The same when we provision an AWS instance with Terraform. To create an AWS instance with Terraform, we make use of the AWS provider, and the resource type that we need here is AWS instance. The required arguments here are the AMI, which is the Amazon machine image, and the instance type. Many attributes of the AWS instance resource will be known only after creating the AWS instance, and they will not be shown in the output of the Terraform apply command. In this situation, we may need output variables. Output variables can be useful if you want to make information available on the command line while running the Terraform apply command, or also to make certain information accessible for other configuration scripts or tools. Let's see now how to declare an output variable. To define an output variable, you need first of all to add a block of type output. The output keyword here will let Terraform know that this block is used for declaring an output variable. The label immediately after the output keyword is the name given to the output variable. This name can be used later to access the value that will be stored in this variable. Inside the output block, we set the value argument to an expression whose result will be stored in this output variable. You can declare output variables in the same file with the resources that you want to provision, or you can declare them in a separate file called, for example, outputs.tf. Let's go back to our first example and see how we can display the random integer on the command line using output variables while running the Terraform apply command. We have here the same configuration file that we have used to generate a random integer, and we have added a block of type output. So this block is used to define an output variable, and the output variable here is called generated value. The value argument of this output variable is set to the result attribute of the randint resource, which is a resource of type random integer created using the random provider. So here at Terraform, we'll first of all create a random integer resource called randint and generate a random integer that will be stored and accessed using the result attribute of the randint resource. And because here we have set the value argument of the output variable called generated value to the result attribute of the randint resource, the random integer that will be generated will be stored in this output variable. Now when we run the Terraform apply command, all the output variables with the value associated with each one will be displayed on the command line. The same thing if we want to display the public IP of the AWS instance on the command line while running the Terraform apply command. In addition to the resource block used to provision an AWS instance, we will add another block of type output to declare an output variable called instance public IP. In this block, we set the value argument to the AWS instance, which is the resource type, .instance, which is the name given to the resource that we want to create, .public IP, which is the attribute of the instance resource, where the public IP of the AWS instance will be stored. Now by running the Terraform apply command, Terraform will create the instance and will display the public IP of the instance in the outputs section in the output of the Terraform apply command. Another way to display output variables on the terminal is using the Terraform output command. By running this command, Terraform will display all the output variables with the value associated with each one. If you want to get just one output variable, all you have to do is to specify the name of the output variable to the Terraform output command, as we did here with the instance public IP variable. When declaring an output variable, we can use the precondition block argument to add some custom conditions check. In the example that we have here, we set the condition argument of the precondition block to random integer dot randint dot result greater than 15. So if the generated value is greater than 15, it will be displayed on the terminal. Otherwise, you will get an error indicating that the condition is not met and the generated value is equal or less than 15. In addition to the value and the precondition arguments, we can use the description argument when declaring an output variable. Like input variables, the description argument can be useful if you want to describe the purpose of using this variable and the value that will be stored in it. If you use an output variable for storing sensitive information, you can set the sensitive argument to true, and this will hide the value stored in the variable when running the Terraform apply command or the Terraform output command without specifying the name of the output variable. But if you run the Terraform output command followed by the name of the output variable, the value stored in this variable will be displayed on the terminal, even if we set the sensitive argument to true. So that's it for this lecture. I hope that everything is clear, and see you next time. We will talk in this lecture about resource dependencies in Terraform. We have seen until now how to create resources with Terraform without any dependencies between them, which rarely happens in real-world resource provisioning solutions. Here, for example, we have a configuration file for creating two resources, a random integer and a local file. The two resources are independent of each other. That's why they can be created in any order while running the Terraform apply command. In real-world scenarios, a resource may depend on another resource or a group of resources. For example, in Azure, we have what we call a resource group, which is a logical container for grouping and managing Azure resources. It serves as a way to organize and manage resources based on their life cycles, their applications, or their environments. A set of resources within a resource group are deployed, updated, and deleted together as a single management unit. So for provisioning a group of resources related to each other in Azure with Terraform, first of all, we need to create a resource group and then provision the remaining resources that should belong to the resource group that we have created. So that's an example of resource dependencies. One way to make a resource depends on another resource in Terraform is to reference a resource attribute in the resource block of another resource for setting one of its arguments. We will see how this works in Terraform with simple resources such as a local file and a random integer, and then you can apply that in real-world examples when provisioning resources, for example in Azure, AWS, Google Cloud, or whatever you want. Let's say that we want to create two resources with Terraform, a random integer and a local file. We want Terraform first of all to generate a random integer using the random provider and then store the generated integer in a file called count.txt. We can achieve that by referencing the result attribute of the random integer resource in the resource block used to create a local file for setting the content argument of the file. So in this example, the file count.txt depends on another resource, which is the random integer generated by Terraform, because the content of the file will be the integer that will be generated using the random provider. Let's see how the configuration file will look like. To create a random integer, we declare a resource block of type random integer and call it, for example, randint. Then inside the resource block, we will set the required arguments, which are the min and the max argument. We will assign the value 3 to the main argument and the value 10 to the max argument. Then to create a file, we will declare another resource block and we will set the resource type to local file and call it, for example, a count file. Inside the resource block, we will set the file name argument and the content argument. We will give the value count.txt to the file name argument, and for the content argument, it will be set to the integer generated using the random provider. The integer can be accessed using an attribute called result of the randint resource, and we can reference it in the resource block of the local file like that. So first of all, we mentioned the resource type, which is random integer, followed by the resource name, which is randint, and finally the attribute name, which is result. And this what will make the file depends on the random integer. Now by running the Terraform apply command, Terraform will first of all generate the random integer and then create the local file. An important point to mention here. Terraform will always create the random integer first and then create the local file regardless of the declaration order. So even if the local file is declared first and then the random integer will stay generated before the local file because Terraform will find in the configuration file that the local file depends on the random integer. Let's go back to Azure and see how to provision an Azure container registry that belongs to a specific resource group. To create a resource group with Terraform, we have to declare a resource block in the configuration file of type Azure RM resource group. We give a name to this resource, for example dev rg, and inside the resource block, we have to set the required arguments. So first of all, we will set the name argument. We set it, for example, to dev resource group. And for the location argument, we can set it, for example, to West Europe. Then we need another resource block of type Azure RM container registry for creating a container registry in Azure. We give the name dev ICR to our resource, and inside the resource block, we will set the required arguments. First of all, we will set the name to dev container registry. Then for the resource group name, we will reference the name attribute of the resource group declared previously. And this what will make the container registry depends on another resource, which is the resource group. And finally, for the location argument, we will set it to West Europe. Because here we have referenced the name attribute of the resource group in the resource block used to create the container registry, Terraform will know that the container registry depends on another resource, which is the resource group. So first of all, it will create the resource group and then create the container registry. This type of resource dependencies in Terraform is known as implicit dependency. In the next lecture, we will see how to work with another type of resource dependencies in Terraform known as explicit dependency. So that's it for now. I hope that everything is clear and see you next time. We saw previously that when we reference an attribute of a resource in another resource block for setting one of its arguments, Terraform will detect automatically that this resource depends on the other. For example, if a resource A uses in its resource block one of the attributes of a resource B, Terraform will notice that the resource A depends on the resource B, so it will create first of all the resource B and then the resource A. When destroying them, Terraform destroys them in the reverse order. So the resource A will be deleted first, and then the resource B will be deleted. This type of dependencies is known as implicit dependency because here Terraform we know implicitly that the resource B depends on the resource A. But in some cases, a resource may depend on another resource, even if it does not access any of its attributes. So the question that we might ask here, how does Terraform know what resource depends on the other? In a situation like this, we have to explicitly tell Terraform which resource depends on the other, and that's why this type of dependencies is known as explicit dependency. And that's done using the depends on meta argument. Let's first of all understand what are meta arguments in Terraform. Meta arguments are a special kind of arguments in Terraform that can be used in any resource block regardless of the type of the resource or the provider to which the resource belongs to. So they are not limited to a specific resource type or a specific provider. The depends on meta argument is one of the meta arguments that we have in Terraform, and it is used to set the dependency when a resource relies on another resource but does not access any of the resource data. We will discuss now how to use the depends on meta argument to tell Terraform that a resource depends on another resource or a group of resources. Let's say that we want to generate a random integer using the random integer resource type, which belongs to the random provider. Then we want Terraform to create a file called confirmation.txt containing a confirmation message indicating that the integer was generated successfully and telling the user how to check the value that was generated. In this case, the file resource depends on the random integer resource because the file must be created only after the generation of the random integer is done successfully. So Terraform must first of all generate the random integer and then create the file confirmation.txt to confirm that the integer was generated and to tell the user how to view the generated value. So here the local file resource depends on the random integer resource even if it does not access any of its attributes. Let's move now to the configuration file. As we saw several times, to generate a random integer, we add a resource block of type random integer, and between the curly braces, we will set the required arguments, which are the main and the max arguments. The same for creating the file, we will add another resource block. This time it will be of type local file, and we will call this resource confirmation file. Inside the resource block, we will set the file name to confirmation.txt, and for the content argument, it will be set to the confirmation message. The message can be, for example, the integer was generated successfully. You can view it using the Terraform show command. We will learn how to use this command later. Now, the configuration needed to create the file and the random integer is ready, but there is no sign that tells Terraform that the file depends on the random integer, which makes Terraform knows in which order they must be created. To set the dependency between the two resources, we will add the depends on meta argument to the local file resource block, which will accept a list of resources. here the local file depends only on the random integer. That's why we will mention here only the random integer resource that we have declared previously. You have to know that always to reference or to access a resource, we start by the resource type, followed by dot, followed by the resource name. Now when we run the Terraform apply command, Terraform will know that the local file depends on the random integer. That's why Terraform will first of all generate the random integer and then create the file. When destroying them, Terraform will destroy them in the reverse order. So it will first of all destroy the local file and then the random integer. So that's all about explicit dependency in Terraform. I hope that everything is clear, and thank you very much. In this lecture, we will discuss lifecycle rules in Terraform, but before that we will get an overview about the differences between mutable infrastructure and immutable infrastructure. When we talk about something that is mutable, we talk about something that can be changed or updated after its creation. So for mutable infrastructure, you can continue making changes and updates to the existing object, and there is no need to recreate it with the new configuration. In contrast to mutable infrastructure, we have immutable infrastructure. When we talk about an infrastructure object that is immutable, we talk about an object that can't be changed, updated, or modified after its creation. So if you have some changes or updates to apply, you can't apply them to the current object. The only way to apply them is to destroy the old version of the object and to create a new object with the updated configuration. So we have two types of infrastructure. Mutable infrastructure that can be changed and updated continuously after its creation, and immutable infrastructure that cannot be modified after its creation. So the only way to update it is to destroy the old version and then recreate it with the updated configuration. Terraform treats the infrastructure as immutable. So when we make a change to the configuration of a resource and then running the Terraform apply command, Terraform does not update the existing version. Terraform will first of all delete the old version and then create a new one with the updated configuration. But this is not always the desired behavior. In some cases, we want a new resource to be created before deleting the old version. The way Terraform behaves for updating existing resources can be changed using the lifecycle meta-argument, which is a block that can be nested within any resource block regardless of the type of the resource. We have 4 lifecycle rules in Terraform, and we will discuss them one by one. We will discuss first of all the create before destroy lifecycle rule. We will understand what happens when we set the create before destroy argument to true through a practical example. We have here the configuration file needed for creating a file called file.txt with the content welcome to Terraform inside it. So by running the Terraform apply command, a file called file.txt will be created containing the text welcome to Terraform. If we change the file name argument, for example, to welcome.txt instead of file.txt, and we apply the configuration file again, Terraform will first of all destroy the old version of the file and then create a new file called welcome.txt with the same content. But let's say that we are unhappy with this behavior. So we want Terraform to create the new file first before deleting the old version of the file. We can achieve that by adding the lifecycle meta argument block inside the resource block of the file, and inside this block we will set the create before destroy meta argument to true. And this will tell Terraform that we want to reverse the default order when Terraform perform an update operation for this resource. Now when we run the Terraform apply command, Terraform will reverse the default order followed for updating the resource. So Terraform will first of all create the new file with the updated name and the same content, and then delete the old version of the file. This can be beneficial if you have, for example, a server running your application and you want to make some changes to the server with Terraform. So it is better to tell Terraform that the new server must be up and running before deleting the old version of the server to avoid any downtime of your application. Let's move now to the prevent destroy lifecycle rule. The prevent destroy meta argument will allow you to protect resources from being destroyed by preventing Terraform from applying any plan that would destroy the infrastructure object associated with this resource. For example, if we have a file created by Terraform and we have the prevent destroy meta argument set to true, when we run the Terraform destroy command to destroy the existing infrastructure object, Terraform will prevent the plan from being applied, and it will throw an error indicating that the local file can't be destroyed because the prevent destroy meta argument is set to true. We will get the same behavior if we try to make a change to the local file, for example, changing the file name from file.txt to let's say count.txt, and then running the Terraform apply command. Terraform here will generate the same error for the same reason. The only way to destroy a resource object having the prevent destroy meta argument set to true is either by removing this meta argument from the resource block or by removing the resource block from the configuration file entirely, which will lead to removing the prevent destroy setting along with it. And this can be handy when you want to protect critical resources managed by Terraform, such as database instances from being deleted accidentally. Let's see now how to work with the ignore changes lifecycle rule in Terraform. After creating a resource with Terraform and making some changes to the configuration, when running the Terraform apply command, Terraform will compare the current state of the resource object to the new configuration, and it will try to update the resource object as mentioned in the configuration file. We will talk about state in Terraform later in more details. The ignore changes feature is intended to be used when a resource is created with data that may change in the future but should not affect the resource after its creation. For example, here we have this configuration file containing a resource block for creating a file called welcome.txt containing the text welcome to Terraform. And we have the ignore changes meta argument set to a list containing just the file name attribute to tell Terraform that any change made to the file name attribute must be ignored. When we run the Terraform apply command, Terraform will create the file as mentioned in the configuration file, and if we change the file name in the configuration file, for example from welcome.txt to welcome to terraform.txt, by running the terraform apply command, Terraform will display a message indicating that the infrastructure matches the configuration, even if the file name was changed. That's because we have told Terraform to ignore any changes made to the file name argument using the ignore changes meta argument. You have to note that only attributes defined by the resource type can be ignored. For example, for the local file, you can ignore changes made to the file name or to the content argument, or both of them, but we can't ignore changes made to meta arguments, which are the arguments that can be used with any resource type, like the depends on meta argument, for example. Finally, we will talk about the replace triggered by lifecycle rule. The replace triggered by lifecycle rule can be used when you want to replace a resource whenever a change is made to a group of resources or resource attributes. Let's understand that in more details. Let's say that we want Terraform to generate a random integer and to create a file. Then, whenever the content of the file was changed, we want Terraform to generate a new integer which will replace the old version. For example, if the content was changed from 15 to 25, Terraform must recreate the file with the new content, and the random integer must be replaced also. Let's see how to achieve that in Terraform using the replace triggered by lifecycle rule. We have here the configuration file needed to create a file and to generate a random integer. In the source block of the random integer, we will add the lifecycle meta argument, and we will set the replace triggered by meta argument to a list containing only a reference to the file name attribute of the local file. When we apply this configuration for the first time, Terraform will create the file and generate a random integer. Then if we take the same configuration and we change just the content of the file from 15 to 25, now by applying the new configuration, Terraform will first of all delete the old version of the file and the old version of the random integer, and then it will recreate them using the new configuration. So here we didn't change anything related to the random integer, but by applying the new configuration, Terraform delete the old version of the random integer and generate a new integer, and that's because we have told Terraform that the random integer must be replaced anytime the content of the file was changed. And that's done using the replace triggered by option of the lifecycle meta argument. If we set the replace triggered by option to a list containing a reference to the file and not a specific attribute of the file, the random integer will be replaced whenever a change is made to any attribute of the file. So anytime the file name was changed or the content was changed, the random integer will be replaced. So that's it for now. I hope that everything is clear, and thank you very much.